Okay, so we are saying an atom will basically be divided. We have got different types of quantum numbers and we have got four of them. The first quantum number, which describes where an electron is going to be found, is a principal quantum number. Okay, principal quantum number is going to tell you the shell where the electron is found, and so it is given by n. And then when you have got this principal quantum number, which is a shell, shells are going to be divided into subshells. Since shells are also called energy levels, they're going to be divided into sub levels or subshells. And subshells are described by the angular momentum quantum number given by the letter L. I don't want you to understand very much this in, just know them. That's why I'm not writing the quantum numbers themselves. I'm just writing the symbols because this is a topic in chemistry. Here I'm just making you understand because the way they are going to teach you in biology, it is very difficult for you to understand all when you for you to understand everything about it, because they'll just be mentioning things and for you to master, they expect you to master. But if you understand it from chemistry point of view, then very easy. And then the subshells are also going to be divided into orbitals. An orbital is a region around the nucleus of an atom where the probability of finding an electron is maximum, and orbitals are described by the magnetic quantum number m with a small l down. Now, you need to know there's a difference between an orbital and an orbit. Okay, an electron is going to be moving around the nucleus like that. The path that the electron takes around the nucleus is called an orbit. But where the probability of finding an electron, the region around the nucleus, where the probability of finding an electron is maximum, is an orbital. An orbit is a path. An orbital is where you are likely to find an electron. So remember we said when you have got n is equal to 1, this is the first shell. The subshell or the angular momentum quantum number is a number from 0 up to n minus 1. So if your n is 1, 1 minus 1 will be 0, right? So meaning that L will just be equal to 0. Okay, and then when n is equal to 2, when n is equal to 2, we said L is a number from 0 to n minus 1. 2 minus 1 is 1, so you are going to have 0 and 1 as your L, right? When n is equal to 3, L is going to be from 0 to n minus 1. 3 minus 1 is 2, so L is going to be 0, 1 and 2. And when your n is equal to 4, 4 minus 1 is 3, meaning that L is going to be 0, 1, 2 and 3. When n is equal to 5, meaning that L is going to be what? L is going to be a number from 0 to 4, because L is n minus 1. So L is going to be 0, 1, 2, 3 and 4. Now remember, I mentioned this. Every time you have got L being equal to 0, this is called an s orbital. Okay, when L is equal to 1, this is called a p orbital. When L is equal to 2, this is called a d orbital. When L is equal to 3, this is an f orbital. And when L is equal to 4, this is a g orbital. So this is SPDFG, SPDFG, SPDFG. Please master that. Don't start getting letters which you can't see here. Start putting them where you can't see anything. No. So you can see that for you've got L being equal to 0, meaning that what orbital is that? Emily, what orbital is this? L is equal to 0. What orbital is this? That is the s orbital, right? That is going to be s orbital. But now, since it is coming from the first energy level, we are going to put a 1 in front, so it becomes a 1s orbital. Alright, and then for here you can see we have got L being 1 and L being 0. So we are going to have an s orbital when L is 1, I mean when L is 0, and the p orbital when L is 1. Because they are coming from the second energy level, we are going to put 2 here, we are going to put 2 here. And then here you can see that L is 0, 1, and 2. So when L is 0, that is S, right? And then when L is 1, that is P. When L is 2, that is D. Because they're coming from the third energy level, this is going to be 3S, 3P, 3D. Here you have got 0, 1, 2, and 3. When L is 0, that is S. When L is 1, that is P. When L is 2, that is D. When L is 3, that is F. Because they're coming from the fourth energy level, be putting a 4 in front. 4S, 4P, 4D, 4F. Okay. Someone is late. Yes, we are very good timekeepers. So for the fifth energy level, we have got L being equal to 0, that is an S orbital. L being equal to 1, that is a P orbital. L being equal to 2, that is a D orbital. L being equal to 4, that is the F orbital. Sorry, L being equal to 3, I've swapped them. L being 0, S, 1, P, 2, D, 3, F, and L being 4, that is a G orbital. Since they're coming from the fifth energy level, this is going to be 5, 5, 5, 5, 5. Now, if you, yes, Emily?
For the D, F, and G, what do they mean? Like for S, it's sharp spectroscopic shell. P, it's principal. Now for D, F, G, what do they mean exactly?
Actually, you don't need to know that. It's actually not of our interest, and not anyone will start asking you what does it mean. I actually also don't know. Okay, so
And
mhm,
and the L, remind me L.
L
L,
is
what
the
does it mean?
L is the angular momentum quantum number describing the subshell.
Oh, okay.
All right. Now, friends, from here, okay, remember we also have orbitals. So these which you are able to see here are subshells. Messi, you have got a question?
Yes, I have a question.
Hmm.
Is L always going to be less than 4?
No, it can be more than that. Like when you have got n being equal to 6, then L will start from 0 up to 5.
Then what what's the letter we should use for
And
orbitals?
and you are not interested in knowing when L is actually just know from S to G. And you rarely use actually these two, you even rarely use them. So the most important is SPD. But for that sake, I've introduced also F and G. For what comes after then is none of our interest.
Okay, thank you.
Alright. So what I'm saying is these things you're able to see which I've written here in these are shells. Okay, they are supposed to have orbitals. They are supposed to have orbitals. Now, how do you find an orbital? So this ml you are seeing is an orbital. It is a number from negative L to positive L. Okay, so when you have got L being 0, when you have got L being 0, you don't have a number from negative 0 to positive 0, right? You only have 0, meaning that your orbital is only going to be one orbital, and one orbital can have a maximum of 2 electrons. Therefore, any s orbital will have 2 electrons. Any s orbital will have 2 electrons. When your L is 1, how many orbitals that contain? An orbital is a number from negative L to positive L. So how many numbers are from negative 1 to positive 1? You've got negative 1, 0, and positive 1. There are 3. Meaning that you are going to have 6 electrons because a p orbital has got 3 suborbitals. So a p orbital, it doesn't matter what p orbital, it can accommodate a maximum of 6 electrons. When your L is 2, to find the number of orbitals is from negative 2 to positive 2. How many numbers are those? Negative 2, negative 1, 0, 1, and 2. There are 5 numbers, meaning that you have got 5 orbitals, meaning that a d orbital can have 10 electrons because there are 5 orbitals and each orbital will have 2 electrons. And when your L is 3, ML will be from negative 3 to positive 3. You have got 7 numbers between the negative 3, negative 2, negative 1, 0, 1, 2, and 3. There are 7. Meaning that F orbital can have a maximum of 14 electrons since there are 7 orbitals. And when L is 4, this means that how many orbitals do you have? You are going to have from negative 4 to positive 4. There are 9 of them, meaning that the maximum number of electrons can be occupied by a g orbital is 18 electrons. 18 electrons. Is this okay? Are we moving together? Yes, Amon.
Wanda, kindly repeat your analysis. How to find the subshells?
A subshell is a number from 0 to n minus 1. So if your n is 1, meaning that your subshell is going to be 0 only because you don't have any number from, like n is 1, 1 minus 1 is 0, so you don't have a number from 0 to 0. When n is 2, your subshell, which is L, is going to be 2 minus 1, that is 1. So you are going to have from 0 to 1, get all numbers from 0 to 1, and that is just 0 and 1.
Alright, I get it. Thank you.
Okay, now this you are able to see here. This is also telling you the energy. Now friends, take note that there is nothing like 1p. There is nothing like 1p. For 1 you only have s, and there's nothing like 2d. For 2 you only have s and p. There's nothing like 3f. For 3 you only have s, p, and d. Take note of that, right? Take note of that, very important. So I'm going to remove this. Okay, so these arrows I'm going to be showing will tell you how energy, which ones have got lowest energy. So the lowest energy orbital is the 1s orbital, followed by the 2s orbital, and then you have got the 2p orbital, and then next you have got 3s orbital, and then you have got 3p orbital, and then next you have got 4s orbital, and then you have got 3d, 4p, 5s. All right, I'll repeat that. So this is how energy is going to be increasing. Just write arrows like this, just straight like that. Okay, the lowest energy orbital is the 1s. After the 1s, where the arrow ends, go and connect through the beginning of the next arrow. So the next a lower orbital is the 2s, and then go and connect to the 2p. Okay, you go down like that, you go to the 3s, and then go and connect to the end here, 3p, and then go down 4s, go and connect to the end. This tells you that a 4s orbital has got lower energy as compared to the 3d orbital. Hope so. Just draw these lines and they are just connecting. So start with the 1s, you go to the 2s. These two should connect. Okay, these also should connect in this diagonal. In this diagonal they should also connect in this diagonal. That's why I wrote them in straight lines like this. The p's, I wrote them in a straight line. The s's, I also wrote them in a straight line. So meaning that where there's a 5p here, there should be a 6s somewhere here. So a 5p has lower energy as compared to the 6s. Please take note. This is how energy increases. So the lowest energy orbital is the 1s. Now remember, since for the p orbital there are 3 suborbitals, I mentioned that, and you put them like this. Okay, you divide them like that. Yes, Emily. Yes.
So the furthest is the one which has more energy than the closest.
Yes, so these which are more on top here have got lower energy, so you follow it like that. That's how energy is increasing. I hope that's okay.
Okay.
Okay,
Yeah,
so
it's okay.
now what we are saying is that you start from the 1s, this has lowest energy. Okay, you go to the 2p, I mean to the 2s lowest energy, and then you are going to go to the 2p and then 3s. This is how energy is increasing. From the 3s you are going to go to the 3p and then 4s, and then from the s we are going to go to the 3d, 4p and then 5s. From the 5s we are going to go to the 4d, 5p, and then the arrow goes like that. From the 6s, which I have not even included here, we are going to go to the 4f, 5d, and then continue going like that. If you reach to the s again, come here like that. If you reach to the s and then come here like that. So the ones which are down, I've not just shown them. So this is how energy increases. Yes, Emily.
Sorry for disturbing. Yeah, but
Mhm.
so from um 3p has less energy and then 4s has more energy.
Yes, that's correct. 4s has got higher energy than the 3p orbital.
Okay.
All right. Now, remember we have said a p orbital has got three suborbitals. That's why it can have six electrons. So it's divided like this, like this. So one of this box is called the px, the other one is called the py, the other one is called the pz. Depending with the energy level, it can be 3px, 3py, 3pz, or 2px, 2py, 2pz. Yes, now.
So does it mean that a 2p has got high energy compared to 3s?
No. You see, when you are coming from the 2p, oh, you are talking of the 2p. So a 2p has got lower energy because it's on top, and then the 3s is down. So the 3s has got higher energy. You get that? Okay. So these orbitals which you are seeing like this, they have got same energy. So like a p orbital, those, though they are subdivided, these have got the same energy. Okay, and same like the d orbitals, there are five of them, that's why they can have 10 electrons. They also have the same energy. And orbitals with the same energy, they are called degenerate orbitals. Degenerate meaning they are orbitals of the same energy. So 2px, 2py, 2pz, they've got the same energy, and so we call them degenerate orbitals. Alright, so they should be connected orbitals. Now this is important for you to know, because when you are filling up orbitals, you need to fill the lowest energy orbitals before filling higher ones. Fill lower energy orbitals before filling higher ones. So these rules, there are three rules which you use when filling orbitals. You have got the off-Bohr's principle, you have got Handy's rule or Hand's rule, you have got Pauli's exclusion principle. Now here I don't want you to understand them because you are going to understand them in chemistry. Pauli's exclusion principle says that you cannot have two electrons in the same atom with the same set of four quantum numbers. Alright? So what is going to cause the difference in energy is because of how further they are from the nucleus, like that. Or some of them, like the nucleus doesn't have that much strength to pull them towards itself. Remember, in the nucleus we've got protons, so the protons have got a weaker attraction to them. Okay, you know that when an atom is losing electrons, which electrons are going to be lost? It is those electrons in the outermost shell. Why? Because they are not closely held to the nucleus. Trust me, when you are in the house of your parents will be able to easily control you. Why? Because you are near them. But when you come to Unza, where you are far from them, you can easily go away from the instructions of your parents which have been giving you. Why? Because you are away from them. That's why also electrons which are in the outermost shell are able to get away from the atom. Why? Because they have got more energy. Like here, where I have got more energy to disobey than the energy you have when you are in the house of your parents to disobey them. So, hope that makes sense. So, the Pauli's exclusion principle will tell you that no two electrons in the same atom should have the same set of four quantum numbers. Now, I don't want you to understand that for now. So, I don't want to explain this.
Tell us, tell us.
No, I,
Let's say just like you are saying.
I don't want you to know. Okay, the Pauli's exclusion principle will tell you that for the same orbital, you can only have two electrons, and one should point up, one should point down. That's what Pauli's exclusion principle tells us. And then Handy's rule tells us that for degenerate orbitals, fill them singly before filling them doubly. Okay, like for the 2p orbital, you know that there are three, right? So if you are supposed to fill this orbital with four electrons, so you need to first fill them singly. So put one electron here, and they should have the same spin. Same spin meaning pointing in the same direction. When you fill them like that, one electron which has remained now comes start filling in here. That is what Hans rule tells you. For degenerate orbitals, fill them singly before filling them doubly, and the singly filled orbital should have the same spin. Okay, that is what Andrew tells us. And for Aufbauer's principle, it tells us that when filling electrons in their ground state, in other words, in their normal state, fill those orbitals with lowest energy before filling those with higher energy. So these basically are the three principles. I've talked about them, or I didn't want to mention them. So let's apply how to write electron configuration of atoms. We are going to start with an hydrogen atom. Atoms of chemical importance or biological importance, since this is biology. So we know that hydrogen has got only one proton, meaning that it only has one electron. So the first orbital to be filled is supposed to be the lowest energy according to Aufbauer's principle, which is the 1s. So I'm going to say 1s. Now, since it has only one electron, you don't have a choice but to put a 1 on top, okay? Because that's the only electron available. So that one on top is meaning electron. Okay, let's go to carbon. We know that carbon has got 6 electrons in the outermost shell. So when you are filling it, you first fill the 1s, and you know that the 1s can have a maximum of 2 electrons, so put a 2 in. So you need to fill the lower energy before going, the lowest available orbital with the lowest available energy before filling higher ones. So I filled the 1s, and then you know that the s can only have 2 electrons. After the 1s, the next I'm supposed to fill is the 2s, and then I'm going to go to the 2s. The s, this is still s, it can also have only 2 electrons, so I put 2 on top. Okay, after the 2s, the next one which follows with energy is the 2p. Okay, now remember the 2p can have a maximum of 6 electrons, but look, we had 6 electrons, we have already used up 4. How many are remaining? 2. We don't have a choice but to put 2 here. That means that for carbon, it lacks 4 electrons. That is why we are going to see that carbon bonds with 4 different things. Like in, that's why you see like carbon bonds like that, because it lacks 4 electrons. Okay, and then let's talk of oxygen. Let's talk of oxygen. You know that oxygen has got 8 electrons in the outermost shell. So to fill up the 8, start with the lowest available orbital, which is the 1s with 2 electrons, and then you go to the next one, which is lower in energy, that is the 2s with 2 electrons. From the 2s, you're supposed to fill up the 2p. Okay, now remember the 2p can have 6 electrons, so you've already used up how many? 4. So from the 8, how many are remaining? 4 are remaining. Okay, so 4 are remaining, and you don't have a choice but to put the 4 there. So you can see that the p orbital should have 6 electrons, but this one only has 4. That is why oxygen gains 2 electrons to make sure that it fills up the p orbital. Is there a question? Do we have any question? Any question? Okay, there is no question. Yes, please. Mm. Yes. Yes. All right. Musonda, you also have a question?
Yes. So when writing, you can just write it as 2p instead of writing it as 2px, 2py.
Yes, you just write 2p.
Okay.
All right. So let's talk of another atom. Let's talk of yes.
Can you repeat on oxygen again? In that jam, network.
Okay, you are going to understand on phosphorus. Okay. So phosphorus has got 15 electrons. So when you are filling up, remember you first fill lower energy. Okay. 1s with 2 electrons. From the 1s you're supposed to fill with the 2s with 2 electrons. From the 2s, the lower energy orbital next, actually 2p is higher than 2s, so you're gonna have to fill the 2p. Remember, p orbital can have a maximum of 6 electrons, so put 6 there because we have got a lot of electrons. We've got 15. So 2 plus 2 plus 6, that is 10 electrons, right? So from the 15 we are remaining with 5. When you fill the 2p, the next one is supposed to fill is the 3s. Also fill it with 2 electrons. From the 5 you filled 2, you are remaining with 3. And then from the 3s, the next one you fill is here, that is the 3p. Remember, you are only remaining with 3 electrons, so you don't have a choice but to put here. So this tells you that phosphorus lacks 3 electrons in the outermost shell. That is why phosphorus is going to form a charge of p3 minus. It gains 3 electrons just to fill up this orbital. Okay, that is, so this is how you write the electron configuration of different atoms. So this tells you that for atoms like oxygen, okay, before I explain that, let me just talk of sodium. Sodium has got 11 electrons, so the electron configuration is going to be what? 1s, 2, and then you go to the 2s also with 2, and then you go to the 2p with 6. From the 2p you go to the 3s. Now you've got 2 plus 2 plus 6, that's 10, and then you have got 11 electrons, so you just don't have a choice but to put 1 there. Okay, so when these are forming ions, when these are forming ions when these are forming ions, take note of this. It is the orbital that is in the outermost shell that loses electrons or gains electrons. So when you are talking of oxygen ion, remember oxygen gains 2 electrons like that. So it is the p orbital because it's the p which is in the outermost shell, and it is the outer orbital. This is the one which is going to gain 2 electrons to become 6. So this is the electron configuration for oxygen ion. And then if you're talking about phosphorus ion, the one which is going to gain electrons is this one. I'm not saying it is the one at the end which gains or loses electrons. What I'm saying is that it is the one in the outer orbital. So this one is going to gain 3, it becomes 6. Now you know that sodium has got 3s, 3s1. And you know that sodium does what? Loses 1 electron, it forms a positive charge. So it is this electron which is going to be lost. So you are not going to see the 3s orbital. It will just end at 2p6 because this one is going to be lost. This electron in the 1s and in the 3s, I mean, it is going to be lost. So that will be the electron configuration for the ions. So that means for you to write the electron configuration for the ion, you first need to write for the atom, and then you either add or remove electrons. Yes, please, there is a question.
Yes. Can you repeat the analysis on how it's moving and how it's doing? I didn't get it from broken.
So gaining and losing, you just look at the orbital which lacks electrons. The orbital that lacks electrons, obviously, is the orbital in the outermost shell. Okay, the orbital in the outermost shell. So for this one oxygen, you know that it gains 2 electrons. So it is this p orbital which has less 2 electrons, which is going to gain those 2 electrons to become 6. Then this is oxygen ion. And then for phosphorus, this orbital lacks 3 electrons. You know that it gains 3 electrons for phosphorus, so it be 6. It means phosphorus has gained 3 electrons. Now sodium loses 1 electron. You know that sodium forms a positive charge, so it's going to lose this electron here. So it will only have an electron configuration 1s2, 2s2, 2p6 as an ion. So ions are supposed to have all the orbitals completely filled up. Completely filled up. If it is a p orbital, it should have 6 electrons. D orbital 10 electrons. F orbital 10 electrons. I mean 14. S orbital 2 electrons. All the orbitals should be completely filled up for an ion.